Hi, everybody. Thank you for joining us today. I'm Mia, a product marketing manager at Flagsmith, and I work closely with teams shipping fast and increasingly adopting AI. And one thing that we're hearing consistently is how do you move quickly without adding risk to production? So this is top of mind for everyone right now. And today we'll talk about how feature flags act as that safety net, enabling progressive rollouts, controlled experiments, and instant rollbacks so that you can test and release with confidence, even as systems get more complex. So, with that, I will pass it over to Kyle, who is our co-founder and founding engineer, and will be walking you through the webinar today. All right, thanks, Kyle.
Yeah, brilliant. Yeah, my name's Kyle. I've been working primarily in front-end web and mobile development over the past 12 years. And yeah, helped found Flagsmith back in 2017. Over the last year, I've kind of forced myself very heavily to embrace sort of using AI out of the fear of sort of like inertia. It was actually a young sort of developer in the team that sort of prompted me to do this. I didn't want to be sort of stuck in the mud. I can see this as a sort of technology that's just sort of inevitable. So really embracing it over the past year. And as a result of that, I've sort of got a lot of thoughts around the sort of pitfalls of AI, the sort of advantages, and then how that sort of relates to feature flagging as a whole. So yeah, today I'm going to be talking about how feature flags can be used as a safety net in the AI era of software development. So before I begin, to set the stage, exactly is a feature flag? Maybe a lot of you in the audience know what a feature flag is, but I thought it best to set this context. So simply put, feature flags have become more and more popular over recent years and sort of acknowledged as a best practice tool towards releasing features. And simply put, a feature flag allows you to push code out to production, and that code is not executed unless a feature flag is turned on in an external system such as Flagsmith. And that works for both new and existing features, whereby for new features, what you simply do is write your feature as normal and you surround it in a bit of code that pretty much just like looks like a simple if statement. And that code is only executed once the feature flag is turned on. And that also works for existing features, except the idea is instead of deleting the old code for the existing feature, the idea is you keep the old code and have the new behavior dictated by the feature flag. And that means once you push that code out to production, if the feature flag is off, then the legacy behavior is the one that sort of takes effect, and only the new sort of behavior for that feature takes effect when you sort of enable that flag. And this might seem really simple. So why do we use feature flags? Why has this become popular and sort of recognized as best practice? There are a lot of traditional benefits that have nothing to do with AI in development, and I do see sort of AI in development as sort of like a part of the big sort of puzzle. It's just a tool to a sort of means to an end, albeit a great tool. So let's go through the traditional benefits first. Firstly, and above all else, it reduces risk. So prior to feature flags, you used to have to take this massive leap of faith going from a pre-production environment to production. Regardless of how sure you are in terms of QAs being happy, end-to-end tests all being ready, unit tests all passing, still, regardless of that, unavoidably, you're going from a pre-production environment to where none of your end users are seeing your new feature to a production where all of your sort of end users are using your application. So it's understandable that the act of pushing code out to production was seen as this sort of risky thing and there was hesitancy involved. Whereas with feature flags, if you use them correctly, pushing out code to production does nothing. It's only until you enable the feature flag that that actual feature takes effect. And as a result of that idea, as simple as it may sound, we often get a lot sort of faster code releases. Now, over the past 12 years, as I've been developing software, I can definitely attribute a large percentage of bugs that have occurred due to sort of pull requests staying there stale for a long period of time, getting out of date, getting merge conflicts, you having to deal with that, and then also forgetting the context of the actual feature, the code that you'd written a while back. A lot of bugs resolve around that. And if you get faster code releases, your code is often way more in line with production and in production quickly. So fewer issues result because of using feature flags. And then once the code is in production, again, it's not this big leap of faith going from 0 to 100% of your end users. You don't have to enable the feature flag for everyone. In fact, it's often better to sort of do targeted rollouts. So that could be instead of like you've got like a million users using your application in production, instead of enabling it to everyone, you could enable it for everyone who's using your application, like in London, or maybe a closed beta group. If you've got people sort of opting into closed betas, you could enable a feature just for them first, or maybe like 10% of your users. So again, you don't have this sort of big leap of faith. And actually, what you can do as a result of this idea is instead of enabling for your end users first in production, you can enable for your internal team in production. Now, testing in production was always seen as this hacky sort of bad thing. But if you've got feature flags and you can push code out to production and that code doesn't do anything until you enable the feature flag, why not enable feature flags to your own internal teams in production before your customers? Because historically, what we've tended to do is we've tried and spent a load of time and effort and money replicating production environments and trying to match them as close as possible so that when we test our new features, we get more and more confidence as close as we can to sort of doing the real thing. But ultimately, nothing's real until you test it in production. So now, if the code can sort of live anywhere, why doesn't it live in production? And you test in production because you're replicating the exact same environment that your customers are seeing. Instead of trying to replicate the traffic, replicate the any data. But what you can't replicate is the exact code that's in production because you've got to actually push the code to production to do that. So often there's disparities, and you don't have to worry about that if you're using feature flagging and you test in production. We've seen a lot of customers, sort of large and small, and even in sort of like highly regulated industries, go from having tons of environments that they're spending time and money on to just having um, either just production or maybe one pre-production environment instead of having dev staging, dev 2, dev 3, and that sort of idea. So yeah, testing in production is something that I definitely would recommend looking at doing. Then, as well as that, you can do progressive rollouts as well. So if you're operating at sort of massive scale, instead of enabling a flag for all of your users or big buckets of users, you can start at as low percentage as you want and sort of progressively roll out over time and use feature flags with like APM providers such as Datadog, Dynatrace, New Relic, and that sort of thing. And alongside your rollouts, monitor results. And let's say things do go wrong, because things always go wrong. And historically, like especially with big sort of releases, the ramifications of that were a lot bigger, and rolling back was very difficult because you would have to sort of maybe roll back commits, maybe do cherry picking of commits if you've got like a lot of code sort of like going out there. Whereas with feature flags, the idea of rolling back is you just turn the feature flag off. You fix forward rather than backwards. Fixing backwards is seen as quite a negative thing, whereas instead, what you can do with feature flags, turn the feature flag off, don't roll back any code, just do a fix and push that out at your own sort of pace. In the meantime, users won't see a broken application. Cool. Um, and then finally, it's not just sort of technical things that sort of are affected by feature flags. From a business standpoint, there's a massive reduction in bottlenecks. And what I mean by that, um, before I helped start Flagsmith, I worked on this big medical application, and releases would happen once every few months. And when it got to releasing, a lot of things had to be sort of checked off and sort of ready for that to happen. Everyone had to be happy. QAs had to be happy. product owners had to be happy that the sort of business was ready to roll out that feature or features. And even stakeholders such as marketing, if they're doing sort of press releases that are to do with features that are about to hit production, they have to be satisfied that they're ready as well before the code can go out to production. Not just releasing the feature, but literally just the code. So whilst all of that is happening, your engineers are sitting there getting distracted on this rather than focusing on a new task, and they're waiting for everyone to be ready before they roll out that code to production. In the meantime, it's getting more and more merge conflicts, becoming stale. More and more code is getting piled on top of that in the form of new feature branches. So yeah, it gets more and more complicated. And as well, because of all of this, you have a load of these sort of orchestration meetings where everyone's getting together, spending a load of time and money, wondering if we can push this code to production or not. And we've seen this in sort of like a lot of large organizations, a load of time and money being saved because of using feature flags. And the reason being is that engineers can just focus on releasing code to production because pushing code does nothing until you turn on the feature flag. And that actually empowers non-technical users. It means that QA don't have to rely on engineering and speak with them to sort of enable a feature flag just for the QA team because code's going out to production a lot quicker. And that means they can sort of be impaired without bothering sort of like engineering to turn on the features. And product owners, the same. They don't have to sort of get engineering in once sort of QA is satisfied to say, okay, push the button, push the code out to production. The code's already there. They can just enable the feature flag to whoever they want, whether it's themselves for a demo, maybe it's the internal team, whatever rollout strategy you want. They're empowered to do so because the code's already there. They don't need to rely on engineering. Um, so yeah, that leads me to sort of discussing open feature. Quite early on in Flagsmith's history, we helped start open feature, and if you've used open telemetry, it's the similar sort of thing, but for feature flagging, whereby instead of using a particular vendor's SDKs, you would use Open Features SDKs, write all of your feature flag code to write your application. And if you decide to switch vendor, it's just one line of code instead of doing a massive refactor with syntax differences and that sort of idea. So if you're looking at feature flagging for the first time, or you just want to be sort of vendor agnostic, looking at open feature is definitely something I recommend. Right. Now we get into AI. The good, the bad, and the ugly. Like I say, I've been using AI quite heavily during my software development over the past year, and this is the conclusion that I've come to. So, the good, it types extremely fast. It is just so quick, the things that you can do, and the cognitive sort of offload of context switching. You want to do one thing, then another. You can just simply type the prompts to start you out. And then for large refactoring as well, it's obviously very good. And it changes the way and what we can do with software development. All of a sudden, we can experiment with big ideas without investing so much time and resource. And I do really believe it's transformed how software is built. And I was initially very hesitant, pessimistic around AI, and I forced myself to use it. And if anyone in the sort of audience is sort of feeling that sort of same thing, I think you just have to sort of throw yourself into it because it is inevitable and teams will increasingly over the coming years use it more and more. And I'm just so sure of that. But with that being said, it's not all good. Um, from what I've seen, the main thing is that it's always confident and sometimes competent. When I ask it to do something, when I ask like I'm using AI and I ask it to sort of perform a task that I'm very confident in, I know how it should be done, and I see a result that it's sure that it's getting the right conclusion, but I know for a fact that it's not. Um, it tends to happen a lot, and the idea of it being so confident in the wrong thing can often be seen as quite dangerous. And you do have to have more and more safety nets around your code as a result of this. And actually, the importance of sort of QA and manual checking and code reviews is more important than ever as a result of this. Um, and then also, very importantly, from what I've observed, is the more and more we use AI as teams, we kind of lose control a bit over our own code base. More and more increasing percentages of our code was not written by our team or yourself as a developer. It's actually being automated. And that leads into the main bad and ugly point. Bugs will happen as a result of code that you and your team hasn't written. And the results of that are the team and yourselves not knowing why your application is broken as a result of new code getting introduced because you or your team hasn't written that code. So you've got to start understanding this automated code that AI has written. Um, so yeah, more and more sort of like safety nets and control is required to circumvent this sort of idea. And as one Google anti-gravity user found out, it might accidentally delete your D drive. This actually did happen to someone trying out Google's anti-gravity. Their entire D drive was just completely wiped by AI. So yeah, you've also got to be very careful over what sort of permissions you give AI during your use of it. So, yeah, as a result of that, AI promises speed and efficiency, but it gives you speed. So you've got to be sort of conscious that it is a tool. You do still have to observe the sort of output, monitor sort of quality. And here's how I see feature flagging sort of helping out with this inevitable sort of nature of software development today. So let's say you take this to the extreme and you create an entirely new feature just with AI. I'm just going to hide the video so we can see this entire diagram. Um, yeah, let's say you use AI to create an entire feature and the code ends up being garbage. You could, in theory, with feature flagging, push that code out to production, assuming that it's using a feature flag. And let's say you do, as a result of doing it on purpose, or just it's slipping through the cracks. Um, what would happen as a result of that is your end user, your customers, wouldn't see actually any changes and maybe you come to turn on the feature flag for your internal team and you see this garbage new feature that AI has created, and you see that your application is completely broken. And obviously that's bad, but it's not too bad because there was no downtime as a result of that. Because if you use feature flags with AI, then it's wrapped in that safety net. That code isn't actually getting executed until you turn on that feature flag using an external tool such as Flagsmith. And here we've got a screenshot of you creating a segment that sort of captures your internal users so that you can turn on a feature, for example, just for the Flagsmith team and see the results of this. So that leads on to introducing Flagsmith's MCP server. So with this, you can do exactly what I just talked about, all via a prompt. So the idea is you install the MCP, you say, I want to, whenever I create a new feature, I want to make sure that the AI always creates a feature flag directly in Flagsmith and wraps your code within that feature flag. So you don't have to go to Flagsmith, create a flag. You don't have to come back to your code and write the code to create the feature flag. It all happens during the prompt. And you can even go on to sort of configure rollout strategies via prompts as well. So simply by saying turn this feature on in production or in a dev environment, but only to internal users, you can start to configure your AI to sort of do that sort of thing. And it just means that this sort of AI produced code, especially when it comes to new features, that safety net is just implicit and baked directly into your application such that it always happens. And that leads on to me showing you a demo of all of this working. So if I close this screen here. So what I've got here is I've got Claude Code open. I've got a side project, which is a mobile sort of progressive web app that I'm building. And to the right, I've got Flagsmith. And let's say I want to create a new feature, let's say like a maintenance page that takes over the entire application. I've told my Claude context and I've installed the Flagsmith MCP, and I've told it whenever we're creating a new feature, make sure you create a feature flag. And also enable it in the local environment and keep it off in production so that when we push the code out to production, nothing's actually happening until we turn on that feature flag. So now what I'm going to do is just type a prompt, create a maintenance page that takes over the whole app when enabled. And this is going to be doing a few things. It's first of all going to be creating a feature flag within Flagsmith. It's going to be enabling that feature flag for the local environment, keeping it off of production. And then it's going to get on to actually creating the code to do with that feature. So as we'll see here, we can see here it's sort of it's talking to the Flagsmith MCP, and we see an error here, but I think it will figure it all out. So what it's actually doing is it's going through the MCP, seeing what it can do, and we should see in a moment that it's first of all looking at what features it's currently got, then it's going to create a new feature. And a second. Um, yeah, it's just going to create a new feature. There we go. So yeah, it's created the new feature, and then what it's going to do, it's going to enable it in the local environment. So imagine that all this has happened without you having to go to Flagsmith, and it's going to sort of develop this new feature, but behind the scenes, it's creating this sort of safety net for you. So if we go and enable this, yep, so it's enabled it in the local environment. Then it's actually going to do this sort of development of the maintenance page, and it's going to wrap the code of the maintenance page with the feature flag check. So, in theory, when all of this is done, I could push this code out to production and nothing will happen until I enable that feature flag in production. So we can see here it's thinking about the sort of UI that it's creating. It's using the Flagsmith SDK. We can see here to wrap the feature flag in a wrap the functionality in a feature flag. And as we can see here, the maintenance page is now created. And if I were to disable this feature flag right now and refresh the page, we can see that the application is back. So end to end, what we've done is we've told it to create a feature, and it's not only done that, but it's created all of the feature flag stuff within our project and all of the logic within our application. So yeah, that introduces Flagsmith's MCP. Um, right, yeah, that's the end of my sort of demo and my talk. I guess that now what I'll do is open up to any questions that we might have within the audience. I think we've got Q&A here. Is there additional pricing on use for the MCP server? No, it's completely baked into our initial sort of plan. I think even free users can use it. You just generate a API key. We've got docs that we can send on this. You can just simply install the MCP, create an API key, and use it straight away, even without a plan.
I'm seeing another one as well. How do you keep feature flags from piling up and becoming technical debt as your system grows?
Yeah, that is a great question. So it's massively important. We learnt this ourselves. So we've used Flagsmith since 2017. And actually, I think what I'll do is share my screen again, and I'll show you exactly how Flagsmith is using feature flags in production. Because we've been using Flagsmith on Flagsmith since we've started developing it. So if I share my screen here, I think we can see it. Brilliant. So what we've got within Flagsmith is this concept of stale flags. And what's actually happening here if I filter this? So what we'll do is behind the scenes, we will monitor the last time it's been since you've rolled out a feature flag in a different way, i.e., turned the feature flag on or off, rolled it out to a segment of users. We'll track that behind the scenes. And if it's past a heuristic, like we default to 30 days, but you can set it to whatever you want, we'll tag that feature as stale. So this is kind of like a to-do list for your development team, whereby you should be keeping tabs on this and making a decision of exactly what to do with the feature flag. It could be that you want to delete that feature flag. What we do is we'll go through this list and tag features as to remove and do a blanket pull request that removes it from our code base. But sometimes actually the next step isn't to delete the feature flag. So we've got this feature here that we haven't enabled to everyone yet, but it's been marked as stale. So actually the next step could be to roll it out to everyone, or maybe to a new segment of users. So it's not just sort of feature flags piling up, it's sort of like actions on feature flags. So yeah, we do this through stale flag checks, and then also we've got feature flag analytics, which tells you that your application is still using a flag. So once you've deleted it from your code, I would always recommend referring to this tab here as a source of truth to whether you can delete a flag safely or not. And then just finally as well, what you can do is you can see if we I don't have it enabled in this environment, but if we go to here, we also have a code references feature that we're about to release to everyone. We've got it in closed beta at the moment. But what we can see here is that you can link your projects to GitHub and see exact line numbers of where your feature flags are being used. So yeah, that's how we deal with stale flags in production. Are there any other questions?
Like there was a couple around the MCP and just where to find the documentation. So I've sent that through in the chat as well.
Perfect. And yeah, so even if you're self-hosting, you'll see a section in there for configuring for your self-hosted instances as well. Yeah.
Excellent. Any other questions? No. Okay. Well, wonderful. Thank you everyone for joining today. Yeah, this has been, as always, Kyle, super interesting and illuminating. But yeah, thanks everyone for taking the time. Appreciate it.
Brilliant.